Hey guys, how you doing? This is Coach Scott again, Purple Wave Chemistry, pre-summer, pre-AP Chem special. All right, so let's just get right into our lesson today, or what have you. Let's talk about covalent bonding. Got it right here. Whoop, no, okay, there it goes. It got into focus for us. So, we previously talked about ionic bonding, where there's an electrostatic attraction. All right. After one of those elements steals an electron, it messes up the number of electrons and the neutrality of the element. They're no longer neutral, positive or negative. Covalent bonds, there's not a stealing, all right? There's a shearing of electrons, all right? Shearing of electrons. Now, where the ionic bonds were usually a metal and a nonmetal, okay, most covalent bonds and covalent compounds are made up of two or more nonmetals, okay? Now, if these nonmetals are equally sharing their electrons, we say that is a nonpolar covalent bond. And when we say polar, nonpolar, what we're talking about is if one has got a more positive end than the other. Not like a magnet per se, where they're equal. Okay, that would be nonpolar or covalent. But one is slightly more positive, the other end is slightly less positive than the other one. That's what we mean by polar. So unequal shearing, okay, so the nonpolar, that occurs when there's equal or very similar differences in electronegativity. Okay, well, we're going back to that periodic trend. Now, when there's an unequal shearing of electrons, okay, then we have a polar covalent bond, all right, in which one of the atoms will have a partial negative charge and the other a partial positive charge, all right, because of those differences in electronegativity. Let's look at one, or let's think about this. So these are where the other ionic compounds were just a group of formula units and a ratio of how many per how many, 1 to 1, 1 to 2, 1 to 3, whatever. These are discrete particles. For instance, let's think about H2O. We know and love that one. H2O. Okay. These are two nonmetals. So I've got oxygen. Right? So how many electrons does oxygen have? Well, it's in group 16, so there's 6. Okay. Hydrogen has 1 electron. So the electronegativities are pretty close, right? So oxygen can't steal that electron from hydrogen, but oxygen and hydrogen, they'll make an agreement. What we'll do is we'll share this electron. Okay. Here's another one. How about this? How about we share this one? These two hydrogens. So now we've got 2 hydrogens sharing their electrons with oxygen. And these are what we call electron dot structures or Lewis structures. This lets us know what's going on in the valence shell. All right. So with these two, we see that we are sharing electrons. Okay. Now these are not as strong as ionic bonds. They're not. But they will stay together. Now, another way we can draw this, if we have a single sharing of electrons, is what we can do is we can make a line. A line means that there's two electrons. Then I can put my two lone pair of electrons. They're not really bonded to anything. They're right there. And we'll talk about whether it's polar or nonpolar in just a bit. Okay? But that's covalent bonds. I can do several. Let's do one. Let's do methane, CH4. I got carbon. Okay? Carbon has what? 4 valence electrons. It's in group 14. All right, so I'm going to throw those 4 electrons up there. Then hydrogen, like we talked about, has 1 electron. It'll share it there. Has another one there. They'll share it. Another one is sharing with that electron. So now, everybody seems to be happy. Carbon now is being influenced by 8 electrons in its valence shell. Hydrogen, now it's one of the weird ones, it's happy with 2. So it's seeing 2, and again, I can draw this one like that. And I can just put the little lines, which means that they're sharing a pair of electrons. Okay, so these are Lewis structures or electron dot structures. These are just molecular drawing. And so either one would be, unless it depends on what somebody asks, would be acceptable. All right. So that's the big secret to covalent bonding. They're sharing electrons. That's it. Ionic bonds, one of them steals some electrons from the other entity. All right. So that all take care of covalent bonds for us right now. We're going to talk about polyatomic ions, which are covalently bonded atoms, right? That will have a different number of electrons than protons. So it'll have a charge. So these creatures can then become part of a formula unit of an ionic bond. Okay? And we'll talk about that in our next video. And then we'll do a video on what does this all mean as far as differences and how do I tell if it's a covalent or a ionic bond, whether it's polar covalent or nonpolar covalent. We'll talk about electronegativity. So we got lots of things to do, guys. So this is Coach Scott saying, Hullabaloo, Knick, Knick.